Hello and welcome to the second webinar on roof design. My name is Zoltán Tóth and today we are going to talk about the details. Last time we looked at the basics, how to create simple roof structures. Now we are going to go beneath the tile, so let's see what we have for today. Let's take a look. As always, I'm joined by my colleague, Mr. Illes Pap, who's our resident architect.
Hi there.
And he's going to talk about today now the basics, not the basics, but the more advanced side of roof design. But before we go into further details, let's just do two detours. First of all, on the right-hand side, you can ask your questions as always. After the last show, we received several questions. Thank you for that. Whatever you are going to ask during the show, we are going to devote a separate session at the end to talk about these. So don't be shy, ask your questions. Another thing is, I think that would be in order to go through the things that we talked about last time. So let's look at what we had previously. So last time we looked at the basics of roof design, and that basically entailed of how to get started, right? How to create
the shape, how to set up the pitch, how to set up how the roof is intersecting the walls.
That's right.
And today we're gonna go deeper into the details.
Yes, today's session is more about the structural elements. What we have on our menu is basically how to manage your floors, how to create uneven roofs, maybe glass
and
roofs even.
how to set up the framing of this roof structure, how to move the framing, how to set up different kind of structure details inside. Also, we talk about the rafter ending, how to create specific rafter endings. Even we talk about how to decorate the edges of the roof, and we will also cover one specific approach when you draft a roof. Sometimes you don't want to have a complex roof, a full roof with all the planes. You only want to have one single roof plane, and all you know is the heights. We actually partially covered something like this previously. We will talk about that again, but from a different approach, and we will show you how to create a specific roof setting using only one roof plane or maybe two of those, and how to snap them together, how to stitch them together.
That's right. Let's look at the project that we have here. That was the thing that we worked on the last time. If there's anything during this show what doesn't make much sense to you, you might want to check out the previous show. If you missed that one, that's all right. You can watch that later on our website. Yeah. But the two shows make logical sense together. So let's take it from where we left off last time.
So just a quick warm up. This building is actually it's a larger project from a user of ours with two buildings at the top of the hill and one at the side, and there are two smaller kind of conceptual building shapes. We worked a lot on those two in the last session, and today we will also use those, and we will use some of these other buildings as well. Now, first, what I would like to cover is about the floor management, how the floors and how the drawings are managed, and how the representation of those different drawings are managed from the point of view of a roof.
What kind of advice you have in this regard?
Yes, last time we talked about the 2D representation of the roof. I will also talk about that a little bit, but to be able to show what I'm talking about, I think I will just quickly jump back to these two roofs again. For that, I will go back to the 2D, and as you can see on the 2D layout, just as we discussed last time, this is a multi-building project. That means this not only have individual floors, but also the content is separated into logical buildings, and this you can manage always at the floor management button. And here you can find a list of buildings, and there is these three logical units surrounding the building 1 and 2 and 3. They are united together because they are actually part of one single individuum. So I just select this, so I activate the small building parts, and this is it here. And then when I select the roof, by default the roof behaves just as on other building parts. It is represented on the floor where you create it. So when you draft the roof, you will see the contour at least, or depending on the settings, you can see the framing as well. I will go deeper into that soon. But there are two specific things considering the roofs. If you go to the details of the roofs, the settings of the roofs, you will find something that's called the projections and cut.
Yes, we talked about these in
Yeah, we
briefly.
talked about the cutting, how the roof cuts the other building parts, more specifically the walls. But when you talk about the roof, sometimes you not only want to see the roof contour on this specific floor where you are creating that roof, but you would like to see that perhaps below that. And now it's represented with a simple line, but you can change the line shape as well. So now if I do this and I hit OK, now I can't see anything yet because I'm still on the same floor. And actually there is nothing below the ground floor now.
Yes.
But if I insert a new floor below, let's call it garage level or anything else, and then I go and jump to that floor as well, then what I will realize that I will at least see the roof contour. Let's just go one floor below, and as you can see, there's a faint line, and it's telling me that there's the roof contour. Some case you want to use it for drafting purposes, you would like to use it for documentation purposes. It's different. It's differentiated country by country, sometimes city by city. But the reason it's there is that you can control how it's visible, and there is another reason. There is another setting. The same way you can turn its visibility on above the host floor.
So, like you said, you can either use this for documentation or you can use the snap points to further elaborate your drawing.
Yes, and actually there is one another thing why it could be useful. Sometimes, if especially this floor is inhabited, we will talk about this on the other building, but if this floor is inhabited and the roof, I would like to see the roof contour, but I don't want to see it disturbing me anyway. I don't want to be able to select it.
Yes.
Then sometimes what I do and what we suggest is to just simply, there is another floor now, which is called surrounding, but sometimes we call it roof floor or something like that. So you just select this roof and you just move that. It's called object, but you can move the same way anything else. You can move it to the one floor above. And in this case, you will see a clear roof structure on the one floor above, and there is a faint roof structure and the most important parts, the walls. But this comes with a disadvantage, and that's because by default, when you move things from one floor to other, they inherit their 3D position, of course.
Yes.
So
you would need to compensate
is always
for
measured from the zero of the current floor. So if you go one floor above the current position, you move something one floor above, it will be shifted in the 3D.
So you suggest that we compensate for that, push it downwards?
That's the only thing. That's the only thing you need to do. You just need to go there and either in the 3D, this way, just as last time we covered this, you can just graphically push it back down, or if you know the value, I think this time it was like 3 meters, I just typed 3, so now it's back at the proper 3D position, and the 2D and the 3D is now in proper place.
Perfect. Another thing that was missing from last time, and I think it's a good practical advice, is regarding calculations. We talked about listing before.
Yes.
But what about the data such as the floor area just below the roofs?
Yes, well, for this one, I think I will just switch buildings, and I will go and find this other building, which is called Building 1. That's a building with a detailed roof structure, which we covered last time. It's this one here. Let me just rebuild the 3D. It's coming back soon. And then here, at this part, there is this long kind of room, which is this here.
Yes.
Now let me just zoom out and find this here. So that's it over there. Let's imagine this. There is no hole, so it's inhabited. Let's select this roof, and as you can see, there is the hole. I can say that I would like to erase the hole. Let's just delete this hole. Yeah, okay, and it was there. So now it's erased. So let's imagine that for any reason I would like to place a room here, and I would like to highlight what was the useful area. In some countries there is a specific value which if your room is falling under that value, then it's not considered inhabitable. So this value can be controlled here in the settings. You can go and find the item settings, and it's called the minimum area of the minimal height belonging to the net area, and it's this value by default. You can change it here, and this is where it is what's controlling where that specific line, which we will see soon, controls the position in the 2D.
So now we are going to leave it as 1.9, but you know it varies from country to country.
Yes. So now what I do, I just simply use these Roomba walls. I click here and tell, well, this can be a living room or anything else. I can rename it, but the point here is that I can select it. I can go to the details, and the room book or room and area has a specific feature which is called the profile and area properties, and there is this net area. This is how the software can distinguish which is the useful area and which is the useless area. And now let's just make it red so we can easily see where it is, and I can also change the line type, the line weight, and so on. And by default it's not visible because there is an option that I need to use. I need to select it, and in the local menu there is something called the net area on-off switch. So I can turn its visibility on. And if there is this line, it's obviously this part is the lower part, which is falling under that value.
So that's the area south from this line is below 1.9.
Yes. So it's always the lower area is at one of the side, and the taller or the higher area is on the other side. And actually, all the rest is actually calculated here. So if your country is using this or something similar, you can turn it on here, and then also the software will represent that other value, or you can just simply turn off the other one and you can just use one single value.
Great. So much about practical advice. Let's talk about the structural things, because I think that's one thing missing from this, is how we can actually edit the structural elements, the beams, rafters, etc.
Yes, actually, this building part here, as you can see, it is having quite a few beams and all of this structure. Well, let me just jump back again to talk about something simpler and then move on to the detailed one. So going back to the simple building, this one. Last time we talked about how you can set up, and let me just simply make it this roof only visible. So last time we talked about that a roof can be very simple, it can be very complex, and anything in between. So when you say that you would like to work with a simple roof style, this is coming with the software, you will find something like this. If you go with the complex roof style, with tiling layer only, then this is what you see. And anything in between you can control using these values. So if my roof structure is not containing any sort of color beam or something like that, I can turn it off, and I can update the content, and I can see that it's missing there. Same way I can turn off the ridge board, I can turn on off battens, and I can turn off or on any other structure like these here. See, if I turn it on, it's represented. If I do it otherwise, it is coming back. So talking about framing, the rafter, and what I do here is represented anywhere else. The same thing I can do with the battens, something similar is what I can do with ridge boards and so on. So the rafter is especially the rafter is something that is repeating itself using a frequency which is called the beam gap. Mm-hmm. Now this controls the distance between these here. So if you change it, let's just change it to something smaller and update. Now I obviously have more beams. So if I change it to something very large, then I have this here. And sometimes, or actually in many sort of structure, you can see that there is a rafter frame which is kind of stronger than the others. So it has a different cross section. Sometimes the cross section itself is also different, but sometimes it's the same, just with bigger thickness and height. So it comes with something that we call, you can add multi-framing to the same roof. So you don't have to build up one roof, two roofs, three roofs just for the same reason.
But you can have multiple varying sizes of rafter.
You can just add the new one, and by default this new one inherits the settings of the original one, so it won't be visible. But if you say that, well, okay, this is something in between, so I should use 0.6, let's update. Now this way I still only see the same what I already saw before. Yes. But now, if I go to the settings, now this is a simple rectangle, and I go and change the settings of this rectangle and say, well, I don't know, let's just make it half the size. I know perhaps it's too weak, but I think this way it will be very well visible. I think it was original, sorry, I made a mistake, it's there. So it's I turn it off because I don't want to change all the size. So I just change it to half the size of the original, so it's thinner. And then I click update, then I can see that there is the stronger one, weak ones, stronger one, weak ones, and because I use the
three
same
weak ones between two strong ones, and it's plainly visible.
Yeah, and it's because I used 0.6 and it's multiplied by 4, it was 2.4, so I just used the right pattern to be able to set it up, but it's very easy, as you can see. The point is that the software also recognizes that if there is a weak one coming overlapping a stronger one, it won't create two at the same spot. It will just simply remove the weak one. It will keep the other one.
And also you can save this into a style.
Yeah.
So this will be part of your style.
This whole thing is something that you can save here if you're satisfied with the result, or the same way actually you can even create glass roofs or something like that. Let's just go a little bit into that. I don't want to create a complete glass roof
but
here,
this will be the way
as you
to
can
go.
see, there is an I profile, a C profile, an L profile. These are steel profiles that you can use, and you can say that, well, okay, that this here is an I profile, and I changed the material for that. The other one is also something similar. I actually completely remove this here because I only want to see the main frame, and in between the main frame I would like to see something like a glass surface, and it's coming at the roof tiles, because actually this is one layer. As you can see that the layers in geometry contains two layers, and the first layer is used as a roof tile. So I can change this to something like glass. I can position it the way we discussed it last time, and then it falls to the proper place. So this way you can even create a glass roof using the same settings.
What happens if you want to individually move the rafters, beams, etc.? What happens if for some whatever reason you want to modify it by hand?
Let's use the original one. I think I stored it here. Yeah, it was this one. Let's work with this here on this smaller roof. If I just enable it and I say okay, I can see the beams are visible here, and for some reason they are not visible in the 2D. We covered this yesterday, the day before, but I think it's wise to talk about it again. So the way you can control and see them in the 2D is here. So you can just turn on the visibility of the 2D beams, and you can say okay, and then you will see the beams. Now actually in ARCHLine everything is considered as beam, even if it's a button, even if it's a rafter. So it's the structure, it's the framing literally. So if I would like to move this one, for example, here, then I just zoom in, I click on the side, and I say, okay, I would like to do something with the roof framing, and I can make my choice. I can insert a new beam, I can move one single beam, I can move the complete framing. This comes very handy if you would like to, stitch it next to snap it next to an existing wall or something like that. Or if you would like to double the beams, you can just click here and you can say that, well, okay, that's a roof framing, and I would like to insert a new beam, and I would like to double the existing one. Or the same way, perhaps I only want to move this because perhaps there is a chimney coming out, and it shouldn't be there. So I click there, roof framing, and I say, okay, move this beam and move it graphically, or I can type the distance. It should be, I don't know, 0.3, I think 9 meters, yeah. So I just move it 30 centimeters away.
Perfect. So every time you want to edit something, just right-click on that element, go to roof framing, and there you would have all
the software understands
the
where you clicked. If this would be the buttons, there is a secret here in this roof range which I will uncover soon. But if these horizontal lines would be buttons, for example, you can do the same thing with the buttons. You can just you can double the buttons. You can just move them. You can do whatever you want. Obviously, if you cut a hole into the roof, it will remove these parts, and then you can snap the framing next to it. And actually sometimes if the roof is much more complex than this, you will find by default things where the software cannot just figure out automatically how these rafters or any other parts should be snapped together, because if it's snapped here, then it cannot be snapped on the other side. So you can solve it manually by simply right-clicking here and say, okay, this roof framing, the whole framing should be moved and snapping to the other one, and that's it. So now from everything from here is snapped, but the rest is perhaps not that much.
Perfect. You mentioned cuts and holes in roofs, so I think regarding this, you have something to share with us?
It's actually, well, there is one other thing, yes, about how this roof and the wall structure is connected together. But before that, I promised that there is a secret here in this roof. And
let's see that first.
Secret is that actually, if I uncover what it contains, let me just disable the roof layer so we can see only the structure like this. See, now this is interesting because there is this
cavity,
and there is like planking here.
Mm-hmm.
And this actually is made out of battens by simply, changing their widths and heights and just using the same frequency for the distance of battens as the width of the battens, and then this makes like a planking or something like that. So this way, actually, you can also build up another batten on top of this, which really literally works as a batten, holding the tiling, which I will talk about soon. And then you can just build up a way more complex roof structure using this same simple.
Or you could have this method to cover the rafters from below, right?
Yes. Let me just go back to this original roof structure, which we talked about earlier, because this way I can easily highlight this issue with the connection, which comes sometimes when you have the walls and you have this the structure in front of you. Let me just build up only this partial 3D here using this tool here, like that. And there is, if you work with structure like this, let me push it back perhaps, I don't know, a meter more, like that. And again, let me just cut out this 3D just to refresh it. So we can see if the roof cuts the walls. And well, there's a strange cut here, but the thing that I'm about to show is yes, because I have cut inside. But there is one thing here. Let me just go and find whether the projection and cut is okay. And it's not. Why? It's because, remember, last time we set this roof to cut walls only on its own floor. But now we move this whole structure to a different level.
Yes,
so there is no wall there. Actually,
right.
roofs, walls penetrating that floor are coming from another floor. So to be able to cut them, I should enable at least this, or this will also work. So if now I click OK, then and I cut the building like this way, so it's I not cut off this part, unfortunately. Then everything will be okay. Now,
yes,
now the walls are cut.
That's the way to control where you want to cut.
Yes, now the walls are cut. There is another thing that I'm about to show you here, and this part is under the roof structure, and that's happening here. So where, how can I determine where this cut ends, and should it penetrate the cavity in between the framing or not? This is something that's controlled also inside the software, and you can change the settings. If you're happy with this, then it's just fine. If you would like to change this, if you would like to shift this away someplace else, then you can use the projections and cut, and there's this value. 0 means that it's where the original plane is, but if you would like to shift it, I don't know, let's just use 10 centimeters, update and OK, and then just update this partial 3D. And then we will see this line should be moving somewhere. So this positive 0.1 means it's moving up. But the same way, if I use a negative value, I can further push it back down for any reason. So this is what controls where this cutting plane is.
Perfect.
So what was the question before?
That's actually in connection to that one. There was something else regarding cutting the roof planes.
Yeah.
But I think we have already demonstrated that last time with the terrace.
Yeah, so I think cutting the roof planes I will talk about again now when we talk about these roof planes drafted individually. There is another way. So let me just erase this roof. This here.
That was before you actually do that. There's one topic that ties into this one perfectly, and that is firewalls. Because now you're talking about how the roofs are cutting the walls. But there are scenarios when you want the walls to actually exceed the roofs, obviously not through them, but next to them.
Yes, you're
how
right.
How do you make that happen?
Yeah, so let's go back and first things first. I'm just making this roof a little bit more simple. I just disable this here, and well, this is easier to handle for now. And then I go back one floor down. I will just extend the roof a little bit, so it's covering this part as well. It should be. I'm making the ground floor visible, and then I just simply extend this. So you remember we also talked about this,
yes.
that you can actually change the roof shape itself, the whole roof structure. You can just change one side. Now I'm moving the structural edge, and I make it completely a different roof. And now I just make this shorter. Now I could move this, but still, because there is this overhang value, which I believe that we discussed last time, but let's just refresh this. It's here. It will always make the roof a little bit longer than the original boundaries. So I can actually click here on this plane edge, and I can just offset this plane edge behind the wall, which I do not want to cover because I want this wall stick out a little bit. Let's just rebuild the 3D again, this way, and have another look at this, and we will see. Let's just go to find the nice axonometric view. It will be easier to handle for now. So we can see that it's definitely something of a beginning of a firewall, but it's not there yet, because many times I just would like to follow the same shape as it's originally there. So the first step there is perhaps I will change its height. That's fine, but still somehow I need to chop off these. I cannot do that with the roof, because obviously in that case I have to cover with it. So there is a solution to that, and it's kind of a uniform solution for all of the walls and all the times when you would like to change the shape of the wall, and it comes in the local menu of the wall. Now keep that in mind, that now it's important on which side of the wall you click. So if I click on this side of the wall, I can edit this side of the wall. If I click into the internal side, then that's a different shape. Side would be edited. So if I click here and I say, okay, this should be a new profile, and I would like to add a whole frontal profile, I would like to change the whole frontal profile, I can do it in 2D. And the way it goes, I can just, draft the shape. And then this is how it will look like.
Yes, it's not
now the connection is not correct because I did not connect, make a T connection between the other two, but it's there. So the ideology behind is this. Just
another way would be, and that's something that we already discussed during the Gateway to BIM webinar series, is that you get an elevation view of your existing drawing, superimpose the profile drawing on it, and then you can just copy the nodes.
Yeah,
so there are many ways to
actually.
You can many ways to do that, but this is the idea behind it.
This is the idea, and I would like to show you another thing. But before that, I also show you how to solve this. The reason it was having this strange connection here is that because they are equal in this connection. So it is coming a 45 degree angle cut, a 45 degree angle cut. So there will be always one roof part or one wall part which is not taking part in this connection. So to solve it, you can actually T-connect these together, and in that case this is weaker. It's just bumping into the other wall. And we will see it happening here right away when I'm doing it now. It's a 45 degree angle connection, but when I come here and I say, okay, just T-connect this into this here,
yes, then it's solved.
It's solved now. So now whatever I do with this wall, it won't have that strange connection. So the other thing that I wanted to show you, and I think this is what we discussed last time together, that we should talk about this, it's that the same thing you can do in 3D as well. So you can right click here and you can say that you would like to reshape this frontal shape, and you would like to add a whole frontal shape, or you just would like to edit this front profile. And in this case it's easier because I'm just saying that, okay, move this somewhere over there, move this somewhere over here. I can of course use values, and let's just insert a node, a nice node here in the middle point, and let's just say, okay, I'm done. Now there is a wrong connection there. So
it's just a matter of how you connect the walls, and maybe the roofs should be extended some more, but that's actually the idea. Now let's talk about some more roof editing tools, and one thing that comes up in mind is that how do you cover the nether part of the edge of the roof? Let me explain what I mean. You have this roof part over here, but there are scenarios when this part is actually covered in some cases, some way. How do you add that?
Well, there is two ways. One is the conceptual way, and it's when you go back and have this conceptual roof shape, which was this simple roof, update, and that's it here. Then whatever the roof ending looks like, it is controlled by the this layered and geometry, and it's here. So you can tell the software that actually the ending is something like this,
yes,
or like this. It really depends on both ways. You can set up a vertical thickness. You can tell the software that actually something here happens like 0.05, like only 5 centimeters. And when I say okay, then this is what I will get. And with the other solution, it is trying to catch up with the wall. But this is just conceptual. So if you would like to have some more detail, you obviously should go with the decoration profile.
Yes, we'll talk about that at the end.
Which will be part of the other roof. Yeah.
Now we talked about automated roof styles in the beginning during the first session, but there was one aspect that we haven't covered, and that is the flat roof.
Yeah.
Now, creating flat roofs can be done several ways. You can also use a piece of a slab to cover your locations, but if for whatever reason you want to have an actual roof being superimposed in your building, then you can add a flat roof. And in connection to that, there's a couple of other roof shapes that I think we should show, because they are predefined and you don't have to build them up yourself, but you can use it from the library.
Yeah. Well, the flat roof is designed, just as you mentioned, two ways. There is this roof, and it's called the roof shapes, and there's this flat roof. It's really simple. You only need to find the contour which you would like to cover with that, and say, well, it's the whole building, for example, and then there is a slight pitch in this roof, which you can go there, and the same way, just as we discussed last time, you can go to the pitch and shape, and you can change its pitch. Let's just change it, I don't know, like 5 degrees, update, so it's slightly pitched, and you can say okay, and now it's there.
Yes, and again, you can set up the cuts to make it cut the walls. Can you go back to the automated roof shapes, because there's some other thing what I think we should talk about. So there's actually quite a few shapes here. Obviously, you can modify them as you go, but there's one aspect that we have to cover in that is the butterfly, because creating a shape like this one might be challenging, but this is a good starter point where you can actually place this, and you can define how the roof planes are pitched.
It's absolutely simple, and still you have the option to change the roof planes later. Now we are talking about a projected roof, and this is the time when we start to go into the direction where we will have now talking about the roof windows and the projected roof Dorma roofs. But the point here is that there are specific roof shapes that you can just simply draft and set up different angle. You can even make it like asymmetrical or something like that,
like we did it 2 days ago.
Yes. So the same way you can change it, and if it's even more complex, like I don't know, it's like one triangular shape here, another one here, another one here, you can use the tool that I'm about to show you now, and that's called the roof by 3 points, or the roof by reference line. And this comes here in the roof. So now, last time and on the current section, we talked about the first two options only, but there are quite a few here as well, and that's the roof plane by reference line, the roof plane with 3 points. P3 is for 3 dots, 3 points in the 3D space. So how this works? Well, let's say this is a building. It's actually a room, which I went on the spot and I measured. And last time we had this little drawing about, I measured the wall height, it was around 1 meter, and there was a horizontal value of this pitch and the vertical value, which I can use. I will cover that pretty soon, but there is the other way, when I just go to the spot and I measure the wall and I measure the ceiling. And that way I know that in the corner the roof was, I don't know, 2.4, and here it was like on 1 meter only. And if I know 3 heights of a roof, then the software can draft me a roof plane. So if my job is to only design one roof for two roofs, I mean roof planes, then I don't have to use the big cannon, you know, the automatic roof or something like that. I just use two roof planes and that will do.
Yes,
the
and
work.
then you can do it by plane, and actually this is a very good solution for attic spaces, because that way you can just build it up one by one.
So let's see how that works. I will use this roof plane by 3 points because that's the most of the time used, because we know the distances in the 3D space. So I click on this one, and first things first, again, just as in other cases, I need to tell the software what's the roof shape. Now the roof shape in this first example, it will be the whole room itself. So I just click here, I just follow the contour, click here, and then the second step is that I need to determine the first height that I know. Say I was measuring this here and it was 1 meter. Then I have to add the second point, this here, it was again 1 meter. And there was the entrance here and it was 2.4 meters, so I just click here and it was 2.4. So now the software understands everything and it can draft a nice roof plane for me. So if I just simply select this part and let's just build it up in 3D. Now with all the cut and everything, I will have something can already be considered as an inhabited roof, room under roof.
If you make up an attic space of several different roof planes, do you have to manually merge them, or the software does it for you?
If you draft roofs plane by plane, you will have to stitch them together manually. Let's see an example to that. Let's say this is a bit more complex, and I could see that there was an edge coming here. Perhaps it was like, you know, 45-degree angle or something like that. Then I can easily draft it here. I can tell the software, okay, it was a roof plane. I could see that it was happening like this. So I'm just making it simple now here, like this. Okay, let's just go here, cover it. Oh, I made a mistake here. And that is one of them. The second step here again is to determine the height. This was one height, it was 1. This was another one, it was again 1. And this here, perhaps this one, it was 2.4. So now I have a roof shape. Well, perhaps I used the wrong value. Yeah,
yes.
sorry. Let me just quickly repeat this. So it was the roof plane by 3 points. Let's just keep it simple here, 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 and here. And this was 1 meter. This was 1 meter.
And I think that's this should be the higher value.
Okay, let's make this.
Let's try that one. Let's see if that works.
Yeah. So now I have a roof coming out this way. So if there is another roof coming this way, and so making it a valley, I can draft it here the same way, and I can say that, okay, this is something like a...
But it could be even a piece of a flat roof or anything like that.
Let's just go with this one. Again, I use the same point. See, there will be some overlapping here, which I need to solve.
That is normal.
But again, I need to set up, this was
1 meter.
Again, 1 meter, 1 meter here. And this was 2.4.
Mm-hmm.
See, now they are coming together, and I think I used the wrong value, so they are not matching up. But if the measurement is correct, then they will nicely fall into one.
Yes, but
valley.
you can extend the one on the right. To me, that's not the point. It's more about how to actually do that.
Yeah, and after you can just simply, you know, use the offset and to either use stitch them together this way, or you can use the last tool that we used yesterday, and it's called the, if you click on the roof plane itself, it's called the info and intersection of two roof planes. In this case, it's enough because you don't have complex roofs.
Perfect. So that actually would give you some guidelines, and based on that you can stitch them together. Let's talk about additional roof parts, because there's actually quite a few things we have to talk about here, and that would entail roof windows and dormer roofs maybe.
Yeah, the dormer roof is, I think, let's just move to another roof now, because this will have a good shape. I think I will use this now today, and this is something. No, this one, yeah. So the roof itself has several other options, like the extruded roof. This is what we used just before. It's only giving me, as this little figure indicates there, it will only give me roof planes, literally nothing else. There will be no window in it, nothing else. But if I use the Dorma Roof, and the Dorma Roof is giving me the option to set up a shape with all the walls and windows and everything in it. So let's just go and find the proper building, and it's this one. Let's just rebuild the 3D. Now I'm only interested in that building. I don't want to see all the buildings, so let's just rebuild it like this way. And then I will insert Dorma Roof here, and then I will also show you how to use the regular window, I mean the regular roof window. So I will insert one here or here, and it's used by simply, setting up the Dorma Roof command. There are plenty of tools that you can set up, but which could be something like, well, that's a lot. I don't want to fiddle with all those. But actually, it's much more simple than it looks first. First things first, you need to say that is there a ridge inclination? So this is just simply horizontally stitching out, or should it have some angle? If it's horizontally coming out, you just use 0 here. By default, it has 10 degrees slope. So I just changed that. I won't change anything else, but these are changing, the width of the roof, the height of the roof, and everything else. By default, this roof, Dorma Roof, is set for you to be able to set it on top of the roof, and you shouldn't have to go there and measure what's the height. You only need to select the roof plane and insert it. So this is what I will do. Say I'm happy with this roof shape, okay? Then I just go with the default. I will discuss this when I insert the new one. And then what I need to do, I need to click on the roof plane itself. Now this roof has this very small plane, there's no space in it, and this large plane, but I don't click inside the area because I need to select an edge of the roof, so I click on the side or the bottom or any sort of edge of it. Now the software understands that, okay, this is the roof plane, yes, and I'm able to position it somewhere. And let's say I'm about to put it here. So the software creates the walls, the roof, and everything else, and now it's there. So this complex shape, which would be otherwise a bit difficult to draft, is set back down to properties: the thickness of the wall, numbers of the window, pitch of the roof shape, and actually the shape of this roof. So what happens if I would like to go deeper into these settings? I just demonstrated here. So again, let's use this tool again, and now we change a little bit of those settings. I just go here, I use again a horizontal ridge inclination, but now I will change it from flat to triangular, because this is also very common. And let's just keep this, and by default it's now a negative angle. It will be like a butterfly roof, but let's just change it to, I don't know, 30, 30, and 30. And okay. And okay, again, I keep this on default, and let's just place it here. Now, this is what I get. And the whole point here is that the software is making all the connections between these structures. So if I select this here, which is the roof itself, let's just make a quick cut like last time, so I can demonstrate what happens under the roof. See, there is a hole under it. So this roof structure, the Dorma Roof, automatically cuts everything under from the roof structure, so you can see, you can actually use it when you intersect it. It's a habitable area. So this is what happens there. So it's actually part of the parametric model. It would be a living, breathing part of it. Now, in connection with this, let's talk about the roof window, because I understand they are somewhat similar and somewhat different from the regular doors and windows. Yes, the roof window has actually one specialty, besides that it is having a specific command which is called the roof window. And that specialty is that it's actually its shape. Now there is a window on roof here selected, and this is what I would like to highlight, that in Windows you can actually find a plethora of windows. There's tons of them, and you can even create your own windows and you can use them here. The difference between a roof window and a regular window, both will be aligned with the roof, and they will cut their parts from the roof. Everything will be just as fine, but the 2D symbol will be different. If you just use a regular roof window, a regular window, it will have a horizontal line shape from the top. It's like, it's like a horizontal cut of a vertical window, even if it's aligned with the roof. But if you use a roof window, it will have a nice elongated rectangular shape, just as it should have. So now you should always go to the roof and single and find a roof window shape here. And if you cannot find, then you can go with the rest. So let's just go with this one. I can set up the height, the width and the thickness, and also you can set up the sill height, which can be important if this is again for a space which is inhabited, and then you can measure the sill height. It is also considered it is measured from the floor, just as the regular windows.
How do we position them?
So when you say okay, you can do it on the 2D, you can do it on the 3D. Both actions need you to select on which roof plane you would like to place it. And if you select that roof plane, you should set up the sill height, or you can keep the sill height. Now there are 2 values here which can help you to find the range between the useful values. So now 0.9 would be obviously very, very low. So I should elevate it either to 1.5, 1.6, 1.8 or something like that, to be able to position it to a normal position. Or there is another way. I don't have to stick to this horizontal blue line is actually the sill height. I don't have to stick to that. I can use the free option here, and I can move it anywhere I want. And in that case, the software will calculate the sill height. So that everything here is created like this. And there is one last thing that I'm about to show you. It's a roof connection. You can actually design how the roof window and the roof is connected together. If it's a perpendicular cut, it's just like, it's like a regular cut. But it's also very, I got to say, popular that to have the top cut horizontal and the bottom cut vertical. That's also common. You can set that up and you can use it as well.
We briefly talked about tiling, that how what we see right now is just a conceptual stage, but if you want to get listing out of it, you have to do it in a different way. So how is that different from what we are seeing right now?
Yeah, well, the tiling, and this time again I'm going back to the small roofs, because creating a tiling, you will see it is literally creating tiles themselves, like literal objects as tiles distributed along, and it will make the model quite heavy.
It's because it adds a bunch of more surfaces.
So for this reason, I will just demonstrate it on a smaller roof part, and for that I go back to the surrounding representation and to these small roofs, and I just rebuild the 3D. It's here, and yeah, they are there, and that's the roof which I will talk about now. This is it here. So what we see now, it looks like some sort of plain tiling or something like that, but this is literally only
just a piece of texture, so
which I can find online, or I can use the default built-in texture library. This will give me the surface. It will have a nice visual feedback, but it's not creating real tiles. Sometimes it's necessary for demonstration purposes, for visual purposes, or for simply, doing the documentation and being able to create the right cut right away. So to do that, I need to change how it works within this roof. I go to the roof tiles, and see there is a basic roof, and it's simple. And then there are these objects that I can select. This interlocking round, I think I will go with this plain round. And now there is a question that it should change the roof layers. Yes, do that.
That's what I want that. Now.
Click OK. And then I go back and find the layers in geometry, and actually this is what it was talking about. And I'm sorry, this is what it was talking about. It should turn off the top layer, which happened. But still it's overlapping itself because I did not enable the roof layer. So now the conceptual is merging with the detail, so I should turn this back on. And then this way I can see the tiles themselves now, only because I did not set up anything else. If I would like to start with a different roof shape, I should go with the simple roof, like this one, and repeat this, because now I have all the structure. I should go with the roof layers. I should enable this and this, update, and go back and say, okay, roof tiles. Again, let's just go with the plain round. Yes, update. And then now this is what I have here. Now, what's the problem here and why is it happening here? And why do we see what we see here? Now, first things first, the representation of the roof tile is not as it should have. It's not rounded. And it's because by default, the software is set to display simplified tiles, which are just planes. So I should go with the displaying with the full tiles. Okay, update now, I see the full tiles. Now there is a problem with this tile here because they are overlapping each other. This should not. These should, but this should not overlap itself. And this overhang, which is see the CW value here. This value is 2 centimeters smaller than the tile itself. So if this equals these two value equals, then they are just simply snapping next to each other.
And what about the rows? How can you make them more dense?
Now, this is because, well, there are two settings. Either I align the tiles to the battens or the other way around. Now, let's see, what's the setting for the batten? The battens are set to very far. So now, each batten has tile on them, but there is a large gap between them. So I should use at least half the distance. And in that case, distance of battens, let's just go with 3. And let's just click update. Oh, it's because the battens are regulated with the tiles, but I should do it the other way around. So I should go here and say, okay, battens should be in a shorter distance. And now I have a proper roof setting. Now, if I go and find the roof tiles, let's see what else we have here. We have a different roof tile, a different roof shape, I mean tiling shape, different object. Now these are objects, that's what I'm talking about. These are objects that you can download or create on your own. You can use it on the roof itself. So now going back to the plain round normal, there's one another thing because for this specific roof tile, sometimes we do have a row shift. And it's here. This row shift should be, usually it's half the width of this the style, so it should be 0.09. Update, and then there's a nice row shift here, and all the rest is regulated with these settings. So you can, when there is a cut, you can set up where, okay, the roof tiles are stopping at the whole edge, or they are shifted. This is controlled here. And also there's one other setting that I wanted to tell, and it's about the rest, like the ridge, the valley, and the eaves. This is again something that you can control here. Now we don't have valley here, so I won't demonstrate it, but the ridge works pretty similar. There's always a simple option, or you can set up a real tile and say, okay, this is what I want to see, let's update, and then this is how it ends up.
Perfect. And this will be part of your calculation now. So instead of having simplified objects, you have the real deal.
Yes, and there is one another question which comes up from time to time, and this is this gap here with what we have now, and it's simply there because my battens are not.
So if you pull the battens higher up,
then which comes here, this is where I can determine that the value D should not be larger than this value. Let's just change it to 2 centimeters, for example. There should be 0.02. Update, and now it's nicely coming below.
Up. That's right, perfect. Now let's talk about more of the decoration side of things, because we talked about now the structural elements, but let's discuss how you can cover certain things, because even though you have the structural elements over there, sometimes you want to cover them, but you don't want to make them disappear. You just want to make them hide for a while.
Yeah. So let me load this a little bit more complex roof shape, because there is another thing that I'm about to talk, and it's the ending.
Yes.
So talking about the decoration. The decoration is something that, if it's conceptual, it's easy, it's just a texture, but it's coming to the detailing side, and we would like to use these wooden planks or decorated profiles and so on, then we should use the sweep tool. Now this sweep tool is in the interior, but it's not only for interior purposes, it's for any sort of decoration purpose. It's simply because when you use the sweep tool, you can select a surface, and then you can select edges And the same thing happens when you are in an interior. You can just go and find the room contours and the window contour and so on. So this way you draft the path and you say, okay, I'm fine with that, but I'm not fine with the cross section. And the cross section is again something that you can set up here. You can select from a range of cross sections, or actually you can create your own cross section. Now I don't have a cross section created already in this drawing, so I'm about to create like something
very thin, but at the same time it should be covering the whole thing.
Something like this, for example.
Just use the regular 2D drafting tools to do that.
Yeah. Let's just go with this. I'm happy with that. This will be the snapping point. See, that's the most highlighted point. That's how it's guided through the line. And there is one another thing, and it's the ending here. It's sometimes it should not be just a vertical cut. It is controlled here. This is not a perpendicular ending for me, but perhaps a vertical ending, and it's a vertical ending here as well. And I'm saying, okay, now the software has created that. And I can, again, position it, change the hotspots, change the reference lines, and I can decorate the whole thing around like this.
How about rafter endings?
And the rafter endings are something that they are controlled within the software, I mean, within the roof structure itself. So if I go into the details, I will find the rafter, and there is the ending, and there is the user profile. This is something that I have created or I have selected. This is different from the cross-section profile. So if I click here, I can find that, okay, there is something called profile 4, and it looks like this. Actually, the software is coming with built-in ending profiles. I can select this, I can select this, I can select this. And when I do that, I say okay, I click OK, the software will update that for me, and I can actually create these profiles. These are what we call open profiles. They are not like for closed loops, for cross sections or something, but they are for endings, and there is a dedicated tool in ARCHLine to be able to create open profiles and as well, and you can save them.
Perfect. Actually, that's what we wanted to discuss during these 2 webinars. I hope that we managed to cover the whole process from the very beginning all the way to the tiny details and decorational and structural elements. If you feel that there's anything what was missing from these 2 shows, let us know as always, and next time we are going to revisit this same content with these in mind. I would like to thank you very much for your attention for these 2 shows. We'll see you in September, where we keep on continuing with our show, and the next issue what we are going to talk about is actually walls and wall structures.
And everything in detail.
Everything in detail. So we are going to bid you farewell now, but if you missed it last time, we are going to show you again the video of how we made this studio behind us, because we are very proud of what we did here. So share, join in our happiness when we cherish this studio behind us. Thank you very much. See you in September, actually.
Yeah. See you soon. Bye.